In this video, we will take a look at a few of the features in Excel to do with z-scores, the standard normal distribution, and finding probabilities. So first we want to look at calculating z-scores using the formula, which we have right here, and using an Excel function. So in Excel, you can create your own formula, which would mean writing in a formula that calculates x minus mu all divided by sigma. So we could do that, but I also want to show you then we get the exact same value by using a function within Excel. So first of all, in order to calculate z, you need an x value, you need a mu, a mean, and you need a standard deviation. So for the z-score using the formula, to create a formula, we write equals, and you can follow along with what I'm typing in the cell, or everything that I'm doing in the cell will be also up in this bar here. So equals. Now I want to do the numerator, but I want to make sure that it subtracts x minus mu first before the division. So we should bracket it. And we want it to use the x value that I have here. So I will click on the cell with the x value. And we want to subtract. Over here we have a mean and standard deviation that we will use for all of these examples. So I will click on the mean, and now that's the numerator. We will click the bracket. So it will calculate the numerator, and then I will divide by the standard deviation. And another thing about this particular formula is I want to make sure that it uses that mean and that standard deviation for every single calculation and not looking further down the columns for other values. So we will lock those in, and we won't lock in B5 because the X value is going to change from the B column. We will also want it to do the z-score for the rest of these X values. However, we will lock in the mean and standard deviation by putting in the $sign in front of the column and in front of the row. And we will also do that here and here. So once I have that formula, you can see up here I have equals bracket B5 subtract $G $6 bracket all divided by $G $7. And I will hit equals. And you notice that it calculated the z-score minus 0.625. Now let's take a look at the function in Excel that will also calculate z-scores. Over here, we will click on that cell, type equals, and type the word standardize. And click the bracket. And when you click on the standardize function, notice that it asks you for the x value, the mean, and the standard deviation. So we'll click on the x value, bracket, we will click on the mean value, sorry, not bracket, comma in between, comma, and we will click on the standard deviation. And we also want to make sure that those get locked in. So we will put the $sign in front of row and column for the cell reference for the mean and the standard deviation. And at the end, we will end the bracket and we will click enter. And notice we get exactly the same value. So it is calculating that. Now, I wanted to do that for the other x values that I have here. So if we click on the cell, and you'll notice we get a little box in the corner, and my cross changes from a wide bold one to a small black one, and we will just drag it down. And we'll do the same thing here. When it changes from a wide bold one to, a wide thick one to a little black one, we'll just drag it down. So notice that our x value that is less than the mean, 75, less than the mean, we get a negative z-score. And for x values greater than the mean, we get a positive z-score. And 88, which is actually 8 more than the mean, so it is 1 standard deviation above the mean, actually has a z-score of 1. So all of those should make sense. And so that calculates z-scores given an x value, a mean, and a standard deviation. So you can use the equation that is equals standardize, bracket x mean, comma, standard deviation. That's what it looks like for this function in Excel that I used right there. In this next part, we will look at finding probabilities given an x, a mean, and a standard deviation. And so generally the z-score would be used. We would calculate a z-score from the x, the mean, and the standard deviation. And we would look up a table of normal distribution values, and we will get the probability that any particular value is less than a given x. So for example, if my x value is here, it is 75 and the mean is 80 in the center. You might recall from looking at the tables that if you find the value in the table, it gives you the value to the left of, and I should make that straighter, to the left of any given x value. So there we have to standardize though, so we get a z-score, and that is minus 0.625 that we calculated in the last page with a z-score of 0 in the center. And so instead of using a table, Excel can also do this function. So let's have a look at that. It will give us the cumulative values to the left of any given x value that we are looking up. Okay, now the function looks like this. And in fact, we'll just write it first and then we will type it in just a moment. So the function we're going to use with Excel is equals norm dist and bracket. And it's going to ask us for x, and it's going to ask us for mean, it's going to ask us for standard deviation, and then it's going to ask us, do we want the probability just at this x, or do we want the cumulative value up to that x? And for the most part, we always want the cumulative value up to that x. And the answer we put in here then is true. If we just want the value at a single x, then we will put in false here. But for the most part, I would say we are going to be entering in a true right there. So let's go ahead and type that into our cell for probability to the left of x equals norm dist, and I will open up a bracket, and you'll see it tells me what's the x value, mean, the standard deviation, and are we working cumulative. So the x value is, click on the cell reference there, comma, the mean value is here, comma, the standard deviation is here, comma, and now it's asking me, is it true for cumulative or is it false? And we're putting in true. And we are also going to lock these cell references. If I was just doing an individual one, it wouldn't matter, but I'm going to do a column of them. So we need to lock these cell references for mean and standard deviation so that it always looks in those two cells. And close the bracket at the end and hit enter. So this is telling us that the probability to the left of an x value of 0.75 is 0.26598 or so 2660. Okay, now we could also have it then calculate that for all of the others by dragging that down. Okay, now keep in mind, if you're going to use this function, this gives you the probability to the left of this. So sometimes we are looking for a probability greater than 75, which is mean you're actually looking over here. Remember, to get the other side, we must do 1 minus. and we will find the other side. Okay, one more function that Excel has is, given a probability, you can also find a corresponding z-score. Much like if you've used the table, you've looked all through the table for a given probability, and you match the probability up with the z-score that it corresponds with. So Excel can do this too, with a function that looks like this, equals norm.s.inv, open the bracket, okay? So let's take a look at that. We'll type it here, equals norm.s, and you'll see the options we have here, .dist and .inv. .inv, so almost like an inverse function, working backwards from a probability to a z. So let's open the bracket. Oh, and you'll notice what it needs is a probability. It needs a probability to the left. So I'm going to click on that that probability and close the bracket. Now that probability is not very high, right? So we know that anything less than 0.5 would be negative. Anything greater than 0.5 will be positive. And it corresponds with a z-score of minus 1.34. And let's look at the others. And notice if we have a probability of 0.89, almost 90%, the z-score is 1.24. And 99.67, the z-score is 2.72. And we know that almost all lie between 3 standard deviations. So you can actually check these with a table if you like, and you will see that they do correspond. Now, one more thing that I thought it might be interesting to see is how to create a normal distribution curve in Excel. So what I'm giving Excel are z-scores, and I decided to give them starting at -3 and every 10th. So minus 2.9, minus 2.8, and so on. And you could probably go to 2 decimal places if you like, but I wouldn't go any less than every 10th. I want to get a nice smooth curve. And so you'll notice if I scroll down, -3, and these coincide with all of the ones that are in the table. We get to 0, and then return positive, and so on, right? These particular probabilities that we are looking at are the actual probability at that point. It's not cumulative. So this would be as if we were to plot the curve, -3 down here, 0.0044, so very low. That's its height. -2.9 right here, 0.00593, so a little bit higher. And I'm exaggerating this because I want you to be able to see it. So these are like the y values. These are in a sense, the x values of the points, okay? And so once all of these are graphed, we'll see that it makes a nice smooth curve. And to make the graph, what you do is you select everything, select your x and your y's, or your z-scores and the corresponding heights, all the way to there. That's what it looks like, but I'm going to show you how I get that. Insert. It'll say, I always try to check recommended chart, see what it looks like. And notice the second one down is a nice smooth curve. Let's take a look at that one. We could go there. See, notice this one actually shows all of the heights, and it shows how the distribution mounds in the center and is symmetrical around the other side. So that's a nice one as well to show. Let's click on that actually. And that creates a nice normal distribution curve. If you just want the curve, then you just want the one that is the straight line. Okay? Let's put that over here where you can see it. There. Very nice. Now that function that got just the values at a particular x, not the cumulative one, is where we use the function equals norm dot s dot dist bracket, click on the z-score. All right, so z, and we say false, not cumulative. Okay, so the false refers to the not cumulative. And so it only gives us the height at that particular value, so it is creating the graph. I encourage you to give that a try sometime and have a look. That's all about these functions in Excel, the normal distribution, and finding z-scores and probabilities. Thanks for watching.